welcome back. Let's start. Number 20, find the equation of an ellipse. Vertices 3, 7, and 3, -3. Let's get out some pretty colors just to highlight what's going on there. And then we got our foci at 3, 0, 3, 4. So remember, our foci always lie on our major axis, which they already told us that. But so let's use the foci just to find the midpoint. Well, if this is 0 and that's 4, that means 2 up will find us our center. So our center would be 3, 2, which is huge. Now, this is not a good drawing. I don't know if it goes out farther or what, but all I know is because it's the major axis is my y-axis, I know, generally speaking, it's going to be an x squared over, b squared plus y squared over a squared equals 1 kind. Now let's make some adjustments. The center for my x value is 3, so I got to go x minus 3 squared. And my center for my y value is up 2, so y minus 2 squared. Now our job is to find a, well, technically a squared and b squared. Now, when they told us that the vertices are 3, 7, and 3, -3, essentially, this whole thing is my major axis. So from -3 to 3 is 10. Half of that's 5, which we could have figured out that that's 5 from there to there. And there's my a, because that's my major axis. So if a is 5, then a squared is 25. And now, I got to find b squared. We don't know by information given to us what b is. So this is where we have to resort to a squared minus b squared equals c squared. We do know what a squared is. We already just said it's 25. And where are we going to find c? C is the distance right here, which is 2. From the center to our foci is c, and that's 2. So 2 squared is 4. So if I subtract 25 from both sides, I get negative b squared equals negative 21. So positive b squared equals positive 21. Resist the temptation to take the square root of both sides, because we want b squared and a squared. All right, there's number 20. Okay, number 21, another ellipse problem. Here come the clues. The foci are right here and right here. Now, the first thing I'm going to do before I even read any of this, which don't let yourself, I'm going to find the center of this. Well, if this is 1 to the right and this is 7 to the right, I know from 1 to 7 is 6. So if I go 3 to the right or 3 to the left, regardless, it's going to put me, my center is at 4, 5. Also, because my foci are this way, that tells me that they're on my x-axis. So that's going to be x squared over a squared plus y squared over b squared equals 1, opposite of this problem. So we're on the hunt. First thing we know is this little letter from the center to our foci is c, and we just said that that's a distance of 3. We're probably going to need that. We also know that we can make our x adjustment and y adjustment based on our center. So here it comes, x minus 4 squared plus y minus 5 squared always equals 1. Because it's this way, I know my a squared is going to be here and my b squared is going to be here. Well, look at this little clue. My minor axis is length 4. So what that means is, from the center, I would go up 2, down 2. So we know it would look something like this, because this is 2 right here, which is telling us essentially b is 2, because that's what our b is, half of our minor axis. So I can take that out, square it, and that's a 4. Well, I know c is 3. I know b is 2, so b squared is 4. Again, I'm going to use this formula. And here we go. We're trying to find a squared. So a squared minus b squared equals c squared, and c squared would be 9. So if I added 4 to both sides, I'd get 13. So there's my a squared. Take that out. Put the 13 in there. And there would be my equation of the ellipse described by number 21. All right, number 22, we're jumping into the world of hyperbolas. For the given hyperbola, find the center, slope of the asymptotes, coordinates of the vertices, and the coordinates of the foci. So there's a lot going on here. So the first thing I'm going to do with this one, I'm going to realize that hyperbolas always equal 1, which is a huge clue to take this thing and divide by 100. Now that reduces to 1 over 25. Minus, that reduces to 1/4. And now we're off to the races. So we know, because it's built this way, and these are the easier ones, that our center is going to be 0, 0. How do we know that? No change, no change, no shift. Now remember, in hyperbola world, whatever comes first or whatever's positive, that's our a squared. Now this one just happens to be bigger than this. But if that was a 4 and this was a 25, this would still, the 4 would still be a squared. So don't look for the size, look for the position. So a is 5. And b squared is 4, so b is 2. Now what are these? Well, it's going to tell us a lot. So that means along the y direction, I go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Jack, I'm showing my units, buddy. B is 2. And that is my hyperbola box. What does that do? Well, if I draw in my asymptotes as diagonals, drawing's a little wonky, but I think it'll get the job done. And then I analyze it, and I think, okay, this is a y squared one. So that means it's going to be up and down. Now remember, these are the vertices. Where do those go? That's a vertice right here. Make it bigger, bigger. Those are our vertices, which tells us our hyperbola goes that way. And now with this picture, we should be able to find a lot of information. So I'm going to slide this over. And now we know the center is just 0, 0. Slope of the asymptotes, remember that's rise over run, and I'm going to focus on the center. That's a rise of 5 and a run of 2. So one of our slopes of our asymptotes would be 5 over 2 for one of them. That's this one. This one would be 5 over negative 2, which would be negative 5 halves. So you could probably put plus or minus 5 halves as our slopes of our asymptotes. Coordinates of our vertices, well, right here is 0, 5. So our vertices, 0, 5, 0, negative 5, so 0 plus or minus 5. And the coordinates of the foci. Well, the formula for hyperbolas is a squared plus b squared equals c squared. So we know a is 5, so we square that, we get 25. We know b is 2, so we square that. And we get 29 equals c squared, so we take the square root. So the foci are going to be somewhere here and somewhere here. So how do we identify those? Well, we got to travel the square root of 29, that's our letter C, from the center this way, from the center that way. And the square root of 29 is like 5.5 or 5.6, so it'd be somewhere really close to the vertices, but whatever. The foci would be 0 plus or minus the square root of 29. Because it's got to be inside this parabola and it's got to be inside that parabola. So there's our information for 22A. Now let's just jump right into 22B. 22B is just a mess, so we have to de-mess it. We'll gather our x's together. We'll put our y squareds and our y's together. I'm going to bring that over. And now we're going to get started. Remember, to complete the square, this has to be a 1. So this stuff is easy. It's set up. So we take half of that and square it, which is 4. x squared plus 4x plus 4. But if we put a 4 on that side, we got to put a 4 on that side. Now this one needs some work. This needs to be a positive 1. So that tells me to take out a negative 16, and we got to be careful there. So y squared plus y. Oh, I forgot the 160. That was messing with me. So that's 160. So this would be plus 10. Whoa! All right. All right. So we get 10y plus space, and we're just going to put another space over here. We'll put that over here in a second. Half of 10 is 25. Excuse me, half of 10 is 5. Squared is 25. Now 25 times 4 is 100. So there's 4 of them. So we got 400. And so, but that's a negative 400. So we got to go negative 400 there. And we got 416 minus 400 is 16. So I'm going to clean this up as x plus 2 squared minus 16. Clean this up, y plus 5 squared equals 16. Remember, hyperbolas have to equal 1. We said that earlier. Tells us what to do. So we got to divide by 16. Running out of space. So here we go. So let's get this thing drawn, because doing this without drawing it, I think you're setting yourself up for disaster. So we reduce this thing, we get x plus 2 squared over 16. We see that this is 1. So minus y plus 5 squared over 1 equals 1. Let's find the center. That's left 2, and this would be down 5. So 1, 2, 1, 2, 3, 4, 5. And that's the center. Negative 2, negative 5. Good idea to label that, because you know things are going to kind of be built on that or adjusted from that. So let's go. Well, what is this? That's a squared. So if we take the square root, a is 4. We got to travel the x direction. So this is me speaking. I like to literally move my x-axis and my y-axis. Helps my brain. So 4 units this way. So negative 2, I got to go 2 more this way. And 1, 2, 3, 4 that way. And because it's written like this, I know these are also my vertices, so let's figure them out right now. So if I moved 4 this way, that'd be 2, negative 5. If I moved 4 this way, it'd be negative 6, negative 5. And now we're going to go to this. This is my b squared. So I take the square root, I get b is 1, so I go up 1 from there, which is right about there, down 1, and I'm going to rewrite this so I don't screw that up. Now here's my box. Perfect? No. Is it going to get the job done? I think it is. Alright. Now because it's written with the x starting, that means it's going to go left and right, which means these are my vertices. We already knew that. So we just draw it in there. It's not asking us to draw it, but... Alright. So what's the slope of these asymptotes? Well, rise... That's 2, negative 5. We go up 1, right 4. So let's put this in order. So our center is negative 2, negative 5. Our slopes, up 1, right 4, up 1, left 4. So that's going to be plus or minus 1/4 for both of those. Vertices, we've already labeled them. And now the foci, the infamous a squared plus b squared equals c squared. We already know this is 16 and 1. So 16 plus 1 equals c squared. So 17 equals c squared. Now a lot of people on this Unit 10 test made a little mistake here. If c is the square root of 17, we don't move from this 0, 0 origin. We move from our center, left, the square root of 17, and right, which means we got to adjust our x value, square root of 17. So how do we do that? So our foci are going to be negative 2 plus or minus the square root of 17, that distance, comma, negative 5. And there's our foci. All right, last problem for this video, so hang in there. I think there's a little hiccup, a typo on this one, so we're going to try to fix it, and then we'll just deal with it. So just make sure you don't get wrapped up in the typo. Make sure you get wrapped up in, do I know what I'm doing? So the first thing I'm going to concentrate on is the vertices 1, 1, 3, 1. They're right here and right here. I don't think there's a typo yet, because that's very easy to see, like, okay, my hyperbola is going to open up that way and that way, which immediately I know that's an x squared over a squared minus y squared over b squared equals 1 kind, because it's starting with my x's. That means my Pac-Men are going to be munching the dots on the x-axis. All right, with that being said, let's find the center. So the center is right there. So if this is 1, 1, this is 3, 1, we know that our center has to be 2, 1. So it says find the equation of the hyperbola. We know it's going to be one of these, so now we're going to adjust this with this. So x minus 2 squared over a squared minus, now we got to make our y adjustment, y minus 1 squared over b squared equals 1. And here we go. Here's the hiccup. So the foci 0, 1, I think that's accurate, because see how it's 1 to the left? But if we went 1 to the right, which would need to be true, because they need to be consistent, it wouldn't be 6, 1, it would be 4, 1. So we're going to change this to 4, 1, or else it wouldn't work. Because in this situation, if we were to build our box, we would see that this distance is 1. So A is 1, but then, so I'll write, it's getting messy, but from that, I know A is 1, because our vertices are on that transverse axis, and the whole transverse axis is 2 times A, so half of it gives us A. Now, but this distance is C, same thing as this distance. So if my center is 2, 1, I would need to go 2 to the left to find my foci. So I know C is 2. So if A is 1 and I square it, I'm just going to get 1. So I take that out and put a 1 there. Now I'm going to use the formula a squared plus b squared equals c squared. See if this works out. A squared is 1. B squared we're trying to find. C squared, if C is 2, C squared is 4. Subtract 1, we get b squared is 3, and we're going to replace that with a 3. And there's our answer. Did it. Again, number 1 goal, going viral. Like and subscribe. Thanks.